So the next group of decisions a farmer has to make in the fall has to do with manure and fertilizer applications. So generally, in a growing season in a year in Ontario, there's two windows of opportunity farmers have to apply fertilizer or manure, and that's in the fall, soon after harvest, or in the spring, so close to planting, just around planting, either before or soon after. So, why not the summer? Well, in the summer, there's a crop growing. So, if you're driving across a field, you're going to trample the crop. There's contamination issues if you're spreading manure on a crop. Example, if it's going to be harvested soon, you definitely don't want manure residue in that grain or contaminating the grain sample. In the winter, the ground's frozen. So if you're applying manure or fertilizer, there's a high chance of pollution and runoff. So generally, you got the fall and the spring to do the bulk of your applications. Now, so a farmer has basically to apply manure. Let's just start with manure. They have from the end of harvest to the start of winter when that ground freezes. That's their window to apply manure. So what happens if they apply manure after the ground is frozen? Or in the winter, which the Ontario, our province, defines as December 1st to March 31st for the purposes of applying manure. Well, it's not illegal. A farmer certainly can do it, and sometimes has to. They have no choice but to spread manure in the winter. But if they do that, there's depending on what type of manure, especially liquid manure rather than solid. What you see here is solid manure, which has a lower chance of pollution. But anyway, if they apply manure in the winter, a high risk that there's going to be runoff, and they can get sued if that runoff, that pollution, contaminates and harms someone. So here's an example of a farmer being fined over $30,000 for spreading manure onto frozen ground in the winter. Now, they didn't get fined because they spread the manure. They got fined because that manure eventually contaminated a neighbor's well just a couple days or weeks after application. And the well water, so that person, they had no water in their house. It all just smelled really bad and was brown. And my friend's a country lawyer in Northern Ontario, and he's been in a case where a similar thing, someone spreads some manure and the neighbor sues them because not only are you going to get fined, but now the neighbor, well, okay, they have no drinking water, so okay, well, I'll buy you all the bottled water you need until this problem passes. Well, no, it's not just that. It's, well, I can't do my dishes. I can't cook. I can't boil pasta. So now you have to pay for my food as well, right? And I'm getting filet mignon 7 days a week. And how am I going to take a shower now because I don't have water? So all these things, very complicated. And, just based on my friend, you just don't want to get involved. So it's definitely not encouraged to spread manure in the winter, although, sometimes it has to happen. Okay, so let's say you're a livestock farmer. Well, look, you have animals, and they're not going to stop pooping in the winter or in the summer. So what happens? Well, generally farmers need storage, manure storage on their farms. And, the form of storage depends. Liquid manures, say a liquid hog manure or maybe liquid dairy manure, it's going to be stored in a lagoon or something similar. More solid manure, say beef cattle, that'll be stored in something like a structure you see on the right. These details aren't too important, just so you know that farmers need storage on farm to store manure, so they can minimum of 9 months essentially of manure storage. So they're not forced to spread in the winter. Okay, so the ideal timing is in the fall, sometime after harvest, before winter. They can either broadcast their manure or inject it. Broadcasting, again, what you can see here, that manure is just spread out over the surface of the land. Okay, it's not really incorporated. The farmer's expecting via rain that manure will kind of leach into the ground, into the soil, where those nutrients and that organic matter will stay. The manure will just decompose on the soil surface. And there's also injection, where that manure is buried. You can see here this is an injection machine. That manure is being injected, 2, 3, 4, 5, 6 inches below the surface, where those nutrients are a bit more protected. The odor's kept down. There's not as much of an odor issue. And it's generally seen as more efficient, but it's also much more expensive to do, to inject. It's a lot slower. Okay, a farmer typically, if they have manure, they're going to apply it in the fall, and there's a there can be some problems. Okay, I won't go through all of them, like some issues that are involved with fall applications of manure. Again, there's a whole, you'll take classes about manure, multiple classes. So this is just an overview. But one of the major problems is compaction. Okay, so what is compaction? Well, it's basically you're compressing that soil. And you can see kind of a close up of what that looks like. Just imagine you're driving this huge, heavy tanker filled with, literally tons of manure, literal tons of manure. And that's pressing down onto the field. And in the fall, Ontario, we receive quite a bit of rainfall in the fall. It's cold, so you don't get a lot of evaporation. There's not a lot of transpiration because there's not a lot of crop growth. Maybe you have a cover crop, but even still, you don't have a lot of transpiration. And so you have a wet ground that's very susceptible to compaction. Remember, wet ground is much more susceptible than dry ground to compaction. Okay, so compaction can absolutely be an issue in fall applications. So what you're seeing on your left, for those of you who might be unfamiliar with this site, is basically a tractor with tracks on it, as well as like a manure spreader that also has tracks instead of wheels. The idea with this technology is that tracked vehicles allow farmers to get out on their fields when it's slightly wetter. They get a bit more traction, and so they can actually do field operations when the soil's wetter. And it also reduces the risk of compaction because if you look at the wheelbase, you only have a very small area of the wheel that's actually touching the ground at any one time, the footprint of that wheel. Whereas when you're on tracks, you have, a much larger footprint. And so the weight of the tractor or the weight of the manure or what have you is being spread out on a much larger surface, minimizing compaction. But this is just an aside. Okay, so why is compaction an issue? I mean, this is a plant agriculture course, and we've been talking about manure, not something from plants, for quite a while. Okay, so compaction, the definition is when we compress the soil. Okay, we destroy the soil structure. Essentially, the force of the tractor or the force exerted by the tractor on the soil overwhelms the strength of the soil, destroys the structure, reduces the micropores and macropores, all those fine little spaces between the soil aggregates. That's very important for aeration, for infiltration, and for root growth and development. And so you can see here on your left, you have, a soil in good condition. You can see many macropores and coarse micropores between and within the aggregates. And then once you compact that soil, if you look on the right, you have poor condition. There's no micropores no macropores, and only very coarse micropores. And so what this means is that you just don't have good soil aggregation. Okay, you don't have any place for water or air to come through into the soil, and macropores are also very, very important for root growth and development. And so in compacted soils, you often get very restricted root growth. And you can see an example on your right. This is the entire root system of a corn plant growing in a compacted soil. Excuse me. Normally, a root system would be much larger than that. And excuse me, there's been some really interesting studies done quite recently on how important macropores are for root development. Okay, so just as a reminder, macropores are just very large holes in the soil that allow water and roots and air to infiltrate into the soil. Here's a great study done in the United Kingdom, came out in the year 2000, the interaction between wheat roots and soil pores in structured field soils. So essentially, they took out these wheat plants from the field, and they did with the soil cores intact. They didn't just dig them out of the soil; they kept them intact in the soil, in a soil core, and then they did an X-ray of the soil pores rather. And what they found was that these macropores are incredibly important, and you can see photos here. They call them biopores because these pores happen to be made by earthworms. Earthworms are tunneling through, making these biopores, but really this could be from anything. These macropores are incredibly important for root growth into the depth of the soil, deeper than 30 centimeters especially. So what these guys found, these scientists rather, found that, for the roots that are going deeper than 30 centimeters, those roots are almost always traveling via these macropores. So if you have compaction, you're destroying these macropores. Well, you're not going to have very deep roots. And so this leads to the question, is compaction a silent yield robber? Because you can't see it necessarily. Well, the yields might be lower, but you might not know why, right? Because you're providing it with adequate manure, adequate for nutrients, but you can't see that the macropores, those biopores, are destroyed because, for example, compaction. Okay. So, long story short, this is a potential problem, a potential issue a farmer has to deal with, right? They need to apply manure in the fall window. They have to do it, but they have to make sure that they're doing it when there's a low risk of compaction. And so, basically, soils that are wet are most at risk of compaction. Soils that are dry are least at risk of compaction. And so a farmer's always having to balance like all these things, right? When am I going to apply manure? I have to do it before the winter, but is it too wet? Is it too dry? Or is it too wet to do it? So farmers and agronomists are absolutely paying more attention to compaction, simply because root growth is so key to high yields, right? It's the roots that are exploring the soil, that are obtaining water to help that crop, avoid any drought or water stress. That root growth is needed to explore the soil to collect nutrients and water, etc. So having a very good rooting system is important for crop productivity. And so now that we have new technologies like these tracks, we actually have things like central tire inflation. I won't get into that in this course, but there's new technologies coming out that are allowing farmers to reduce the risk of compaction when operating, say, applying manure in the fall. So, okay, we went over, this window of application that a farmer has to apply manure in the fall. We went over one potential problem, compaction, with fall applied manure. But why would a farmer want to apply manure in the first place? And the main reason is because manure has plenty of plant nutrients in it. Okay, it can be used to satisfy the plant nutrient requirements of the next crops that farmer's growing. And so here's some numbers. So the vast majority of the nutrients consumed or taken in by an animal, by livestock, is excreted in the manure. So, for example, 80% of the nitrogen a beef steer eats is excreted in the manure. 87% of the potassium taken in by a laying hen, etc. So the vast majority is excreted. And so a farmer that's, has livestock and is feeding the livestock, crops that he or she grows himself or herself, well, they want to recycle those nutrients, right? They want to make sure that they're replenishing their fields, keeping the nutrients in their fields, and not having to, say, buy expensive inorganic fertilizer. So that's really the main reason why a farmer would apply manure. There's another one, which is organic matter, I'll talk about at the end. So we can assign a nutrient value to manure. And that's just simply like the amount of usable nutrients in that manure available for crop uptake. Now, the amount is going to depend on the type of animal, the type of livestock. So, for example, poultry broilers, so chicken for meat eating, 24 pounds of usable nitrogen per ton, whereas with solid cattle or beef cattle, it's 3.7 pounds of nitrogen per ton. So, quite a bit more nitrogen available in the poultry manure. So it's going to depend on the type of animal, if it's liquid or solid manure, what was the animal eating, so the feed, a whole bunch of things. But the bottom line is the nutrient value of manure is actually very valuable. It changes over time for a given herd or group of animals. And so a farmer is normally testing their manure to say, okay, well, in this kind of bunch of manure, what's my average nutrient levels? And indeed, in what you see here, you can assign monetary values to the manure based on, okay, if I wasn't applying manure and I had to buy the fertilizer myself, what would the equivalent in inorganic fertilizer be to get those nutrients? And so you can see here a year 1 value and a year 2 to 4 value. And I'm going to talk in a second, why are we dividing it up in this way? Now, it's because manure contains nutrients primarily in the organic form. Now, remember, for a plant or crop to take up a nutrient, it must be in the dissolved ionic form. So, for example, plants are going to take up nitrogen in the form of nitrate or ammonium. Those are two different ions, and they're dissolved in water. But often in manure, these nutrients, these nutrients, like these atoms of nitrogen or atoms of phosphorus, are tied up in larger organic molecules. So that nitrogen might be tied up in a protein. And a crop, a plant root, can't take up a protein. It can only take up nitrogen as ammonium or nitrate. And so often we need these nutrients or these organic molecules to decompose and break down and release those nutrients to be plant available. So in year one, we only might get a little bit of decomposition, a little bit of nutrient release. And then in years 2, 3, and 4, as more and more organic molecules are being broken down and decomposing, those nutrients are released more slowly. So that's why we have two different nutrient values for year one, those ones that are immediately available in the inorganic form. And in years 2 to 4, those are nutrients in the organic form that are slowly being broken down over time and released to the plant. Here's some more data just to show you more, Ontario data rather, that shows you how the nutrients in manure are available slowly over a period of years. So this is the nitrogen release over 5 years from beef manure and liquid swine manure. And you can see that, these are two different release patterns essentially, right? In year one, you have about 35% of the total nitrogen that will eventually be released over 5 years in the first year. So over a third in year one, and then slowly year 2, 3, 4 in the beef manure. Now, in the liquid swine manure, you have 70% of that nitrogen released in plant available form in either nitrate or nitrate or ammonium form to the crop. Okay, so much higher, much more speedy release. Okay. So, if a farmer is applying manure in the fall, it's depending on especially what type of manure is being applied, it can be available pretty much right away. And then there's a synergy that farmers can and are increasingly exploiting in Ontario, which is to apply manure to a cover crop in the fall. Now, a cover crop, again, is a crop that's not grown for cash or grain. It's grown for an ecosystem service it provides. Either it's going to protect the soil from erosion, or if it's a legume, add nitrogen to the soil, many other possible reasons. But here you can see the benefits of applying, here it's poultry manure, to oilseed radish. It acts as a fertilizer to that oilseed radish. And that nitrogen that was in the poultry manure is being utilized by that cover crop rather than, say, potentially being lost in the soil to the environment. Now, another benefit that manure has, aside from nutrients, is that it increases soil organic matter over time. And so generally fields that receive manure, what we call an organic amendment, typically have higher organic matter levels than fields that receive none. Either they just receive, straight up inorganic fertilizer. And so you can see here a large data set from the Soil Health Research Foundation, which found that soils that received organic amendments, and I think they use that other not manure, because organic amendments can incorporate many other things, but it's primarily manure. 3.5% organic matter for fields without, to 4.1% organic matter fields that did have organic amendments. So that's another benefit that farmers are looking for to when they're applying manure.